Hello everyone, tonight's video is over solving a system of equations using substitution. So far we have already learned what a system of equations is and how to solve a system of equations using the graphing method. Tonight we're going to learn the second of the three methods that we are going to learn this year, and that is substitution. When do we use substitution? We are going to use substitution when we can easily solve one of the equations for one of the variables. When we can get one of the variables alone, either y or x, to substitute that into the other equation. Okay, I'm going to show you an example. Notice this system of equations. I already have in my second equation y solved for. I know that y is equal to x minus 3. Those two sides of the equation are equal. So y is the same thing as x minus 3. So what I'm going to do is I am going to take what y equals, x minus 3, and I'm going to substitute it into the y of my first equation. Notice when I do that, I have 3x plus, I'm going to substitute everything that I boxed in, which is x minus 3. I'm going to substitute that where the y was, and I'm going to now finish my equation equals 25. Notice by doing that, I now have one equation that has one variable. We know how to solve this equation. We know the first thing we do is combine like terms. 3x plus 1x is 4x. And then this is simply a two-step equation that I can solve. So I'm going to finish this out. And we get that x equals 7. Not too bad. Now that I know that my x value is 7, what do you think I could do with that? Well, I know that from the graphing method that when I substitute in a value for x, it doesn't matter which equation I plug it into, I'm going to get the exact same y value. That's what makes it a solution. So I can plug this value of x either into the x in my bottom equation, or I could plug it into the x in my top equation and solve for y. Now, which one's going to be easier? Plugging into the bottom equation is going to be easier because that one has y alone. So when I use the equation y equals x minus 3 and I substitute this value of y or of x equals 7 right in there, I get y equals 7 minus 3, which gives me y equals 4. So now I have the ordered pair. Remember, the solution to a system of equations is an ordered pair. I always write it that way. So my solution is 7, 4. So if I got this first equation in slope-intercept form, plugged them in my graphing calculator or graphed them by hand, I would get the solution 7, 4. I could also check my answer by plugging 7 in for x right there and plugging 4 in and making sure that's true. 3 times 7 is 21 plus 4 is 25, so that checks out. I could plug in my 4 right here and my 7 here. 7 minus 3 is 4. So this solution makes both equations true, therefore it is a solution. Okay, now when you look at this system of equations, you notice that neither of these equations are solved for a variable. Okay, so it's not set up perfectly for substitution, but I can see that pretty easily I could take this first equation and I could solve it to get one of the variables alone. Once I have one of the variables alone, I can take the value of that variable and substitute it into my other equation. So what I can do pretty easily is add y to each side. And I'm getting positive x by itself. I'm going to find that x equals y minus 3, or negative 3 plus y. Now that one of my variables alone, it doesn't matter which one it is, either x equals or y equals, but that's your first goal. Get either x equals by itself or y equals, whichever one's easiest from whichever equation. Now I can take what x equals, I'm going to circle what x equals, and I'm going to plug it into the x from the other equation. Not the same equation, or I'm not going to get anywhere. So I'm going to take 2, and instead of x, I'm now going to substitute what x equals, which is y minus 3. Then I'm going to finish writing that equation. Now I have one equation in only one variable. You know how to solve this. So press pause and solve it. Okay, what you should have gotten when you worked it all out is that y equals 6. That's great, but I need an ordered pair, so I need the x value. How do I get that? We take what we just found and we plug it in to either the y in the bottom equation, or we plug it in to the y in the top equation. Doesn't matter which one. Now I want you to look at those and see which one might be easiest. I think there's arguments for both. The first equation has that subtraction sign in front. That's going to make it a little more difficult, but it has x by itself. The second equation, it's a positive y, which is nice, but it's a 2x. So you plug it in whichever one you want. Okay, you could also plug it in to this equation since it's the same thing as the top equation, just rewritten. So that's actually going to be our easiest choice. So I'm going to take x equals y minus 3, and I'm going to substitute in 6 for my y, so I'm going to get x equals 6 minus 3, which is 3. So now I have my ordered pair. Being very careful to write your x first and then your y. Just because I found y first doesn't mean that's the first number in my ordered pair. X always goes first, or the independent variable. We don't always have to use x's and y's. We could use r and s, a and b. But whatever the independent variable is, that's what's going to go in the position of the x. So 3, 6 is the solution to this system of equations. Okay, let's look at one more example together. Okay, here I have this system of equations set up. First thing I want to do is get one of the variables alone, since it's not set up that way for me. So decide which equation is going to be easiest. Again, I think this top equation is going to be easiest, and which variable is going to be easier to get alone? Is it the x or the y? The y. So I'm going to do that, and I'm going to find that y equals negative 3x minus 8. Now what do we do with that? We take what y equals, and we plug it into the y of the other equation. So when I do that, I have negative 2x. Now, I gave you this problem on purpose because you have a subtraction sign there, and we have to subtract the entire value of y. So I'm not just subtracting this negative 3x. I'm subtracting this negative 8 as well. So what I have to do is put the value of y in parentheses so that I ensure I'm going to distribute this negative to both terms that get the negative. Okay, so when I do that, you're going to end up with an equation that looks like this. Now I want you to finish that equation out, get the value of x on your own, then remember you plug the value of x into either equation, the top or the bottom, solve for y, write it as an ordered pair. Then we'll check our answers. Okay, so when I finished this out, I got negative 2, negative 2. I plugged my x value of negative 2 into this equation right here, which is, remember, just the top one rewritten in a different order, because it was the easiest to solve for y. Now, I can check my answer, remember, by plugging it into both equations and verifying that it's true. 3 times negative 2 is negative 6, minus 2 is negative 8, so that top one checks. Negative 2 times negative 2 is 4, minus a negative 2. So 4 plus 2 is 6, so I know I got it right. That is substitution.